Alright guys, this video is going to be on naming ionic compounds and also a little bit on actually writing ionic compound formulas, because it can be a little bit tricky. It's one of those basic skills that takes a little bit of practice. So already here I've got a couple of different types. We have this particular one, and I want you to have a look at this list. If you're able to actually name all of these already, that's awesome, because well, you're already there. But if not, that's not a problem, and I'll be able to help you out. First things first, you are going to need a periodic table. Anytime you're doing sort of any chemistry work, naming, actual stoichiometry, you should always have a periodic table next to you. And if you understand how to actually read a periodic table, that's basically your map to chemistry. It tells you everything. It tells you, if you know how to read it, it'll tell you all the properties and how to predict a lot of things about chemicals depending on their position on the periodic table. So I just so happen to have a copy of this very useful periodic table. It's called the periodic chart of ions. Okay, this is very useful. You can just Google it, Google periodic chart of ions, and you can download this very same periodic chart, and it actually helps you out. Now it's sort of a little bit of a cheat, because it actually tells you and shows you all the common charges, or we also call them oxidation states for ions, being both cations, so positive ions, and also anions, being negative ions. So, and there's also a little table at the top that shows you some common polyatomic ions, and we'll go through that a little bit later. There are some, depending on your level of chemistry, there are some of these you won't actually need to know, but it's good to know. It's good to have a general grasp of what the charges are of each of these, and sort of a general trend of how to name things. So you can already take as a rule of thumb everything in this group 1A. In group 1, so we have hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. That you can already do. That's never going to change its charge. You can already know that everything in the group 1 of the periodic table, they're all going to be positive 1. That's never going to change. So you can already rely on that. Same thing with group 2. Group 2, beryllium, magnesium, calcium, strontium, barium, and radium. Same thing. You could always count on them being positive 2. So it doesn't matter with what anion they form a compound with, an ionic compound, their charge is always going to be positive 2. Let's go over the other side. Let's skip the transition metal ions for now, because they can have, their chemistry is a little bit complex. But I can give you a simplified version. So over here in group 3A, okay, you'll see boron, carbon, and silicon. They're grayed out in this particular chart because they have different properties. They're grayed in this chart because they don't formally by themselves. They don't readily form ions by themselves, but they do form ions. So that we can know, if carbon didn't form ions, then we'd be a little bit in trouble, I think. But as a general rule, in group 3, these ions here have aluminium, gallium, indium, and with the exception of thallium, generally you can see that they all form positive 3, so a +3 charge. And that will always, they don't change, except for thallium. Thallium is a bit naughty, it can change. And that's due to its orbitals, but that's a different topic. And same with group 4 in general, so germanium, so silicon and carbon can as well. They can form +4 charges because of their orbitals if you're learning the octet rule. So for these first first 3 periods here, period 1, 2, and 3, you will learn that in the outer shell it needs 8 electrons in order to actually form a stable orbital. But in higher grades of chemistry, you'll form that they actually have different what we call orbitals, being the s orbitals, p orbitals, also d and f orbitals, but that's in a higher chemistry, and that will be a different topic. But in general, we can have a look at the charges. So tin and lead, we're going to go through those two a little bit later because they can form two very common ions, and you can even commit those two to memory. All right, let's have a look at group 5. Now group 5, basically anywhere, if you see this staircase here, anywhere to the right of this staircase, okay, we call those, well, except for boron, silicon, arsenic, tellurium, and astatine over here, they're sort of, they're metalloids, but everything to the top right of that, we call them non-metals, and they all form, as you can see, and negative charges, so they are anions. Group 5, these three, and particularly nitrogen and phosphorus in particular, by themselves they will form a -3 charge. So nitrides are just nitrogen by themselves, phosphides are just phosphorus by themselves. And same with group here, group 6, you can very make sure that you can be sure that oxygen will always form by itself, oxide will always form 2 negative, sulfide will also form always 2 negative, selenide as well, and telluride as well. Now group 7 is very similar and opposite to group 1 in that they will form always -1. So fluoride, chloride, bromide, iodide, and even astatite, they will always form -1, so that will never change, and you can already know that. So we've already gone through a little bit on how to sort of predict charges in the actual, using just the periodic table. So I hope as we're going through this that you're holding your own periodic table, and you're marking on there sort of the general trends. If you don't have this particular copy, I would recommend having your own copy and not this particular one, because it's a little bit of a cheat. But if you like something a bit easier, I suppose you could take this one as well. Now if you notice here that group 8, none of them form ions because they have filled outer shells, so they are what we call our noble gases, so they're stable, they're not going to form ions. They can at very extreme conditions, but in general by themselves in nature they do not form ions. Okay, let's have a talk a little bit about our transition metals. So this little block here. So the most important ones are this period here. So we have titanium that can form 4+ and 3+. If we have a look at these ones in particular, so if we have a look at chromium, very much so, let's circle that. So basically all of these guys, oops, all of these guys, iron, cobalt, nickel, copper, these guys are quite important. Sorry about the marking. Alright, so chromium can naturally by itself form 3 and 2. So when you're actually naming them, you need to use Roman numerals to actually show the charge of the particular cation. So we have chromium, we have manganese, they can form 2 or 4. Iron that can form 2 and 3. Cobalt that can form 2 and 3. Nickel that can form 2 and 3. And copper that can form 1 and 2. Now the reason for that is actually can be explained when we talk about our d orbitals and also Pauli's exclusion principle, but that's at a much higher level than simply naming them. So that I can explain in a different video. Another couple of common ones. So platinum can be a common one. So platinum can be one that can come up, that can change charges, and also mercury. Now mercury has some very different chemistry associated with it as well. And the other two that can be very tricky, that can pop up, lead and tin. So lead and tin, they can be 2 and 4 both. Other than that, the rest sort of don't really change. They don't really change their actual charges. So groups 1, groups 2, they stay pretty the same. 3, group 3 stays quite the same. Group 4 can change a little bit. The non-metals for group 5, always, most of them are -3. Group 6, most of them are -2. Group 7, all of them are going to be -1. Okay, so that was a bit of an explanation of the actual periodic table. So I'm going to make another video because this video is getting a bit long, and we're actually going to tackle naming those ones back there. Okay, so hopefully this part was helpful, and I'll see you in the next video.